Welcome back, everybody, to the Packet of the Week. With this week, we're going to have the answer to Packet of the Week number 23. So here is the original packet. As you know, this is comes from our VoIP background, and I asked you to decode the first 64 bytes. And that's because when you start getting into some of the voice over IP signaling protocols, things can get a little complex. So we're stopping at 64 bytes. Now, before we do the Packet of the Week reveal, I wanted to remind you guys about a couple things regarding packet decodes. There are a couple of things that we know with certainty, and there are a couple of dead giveaways that you can find in packets. So the red rectangle here represents our layer 2 header. This is going to be the same almost every single time if you're dealing with the same layer 2 protocol. And in this case, we're looking at Ethernet. So you know that in a Wireshark capture, you're going to see 2 MAC addresses and then the type or control field. So all in all, you're going to have 12 bytes. And that 0800 right at the very end is going to be our hint as to what's next. So 0800 in the Ethernet type field means that this Ethernet frame is carrying an IP version 4 packet. Now the yellow arrow there indicates that that's in fact the case. This is the first byte in the IP version 4 header, and that 4 there is a 4-bit field or a nibble that says, hey, I'm carrying IP version 4. And the 5 is the fact that we're carrying 5 4-byte words. So this tells us that the unhighlighted area, the next 20 bytes, is going to be my IP version 4 header. Now the circled 6 there in the yellow circle, that is part of the IP version 4 header that tells us that this IP version 4 packet is carrying TCP. So that's the code. So do you know that the 20 bytes following the 20 byte IP version 4 header is going to be a TCP header? Now, the first thing that we see in a TCP header, as the yellow oval there would indicate, is the value 06B8. This is the destination port address, and this is how TCP tells us what's happening. And in this particular case, the decoded value is 1720. And so that means that this is targeted at H.323 suite of protocols. And in this case, we'll see there's a sub-protocol H.225. So that is your dead giveaway sort of things, and that's how we begin decoding packets. Take a look at known header sizes and then the protocol ID or type fields that are involved in these particular packets. And here is our packet reveal. And we can see that this is an H.323 suite of protocols. We've got an H.225 signaling protocol or setup protocol that is part of the suite of protocols. We'll see later on that there are more sub-protocols involved in H.323. Now, H.323 is a little tricky in the sense that it has to encapsulate all of these very traditional signaling mechanisms. Remember that H.323 comes right out of the ITU-T, and it's an adaptation or a modification of the traditional telephony non-IP based communication protocols. So we have to find some way to transport these over IP networks. And so that's what the TPKT packet for. That's just transport services for our signaling protocol. Q.931 is an ISDN signaling protocol, but this is the packetized version of that. So that's why this pops up here. And then we get into the H.225. So that's the tricky part of this one. You had to know that the minute you saw 1720, you were looking at H.225, which is part of H.323, and that our encapsulation was TPKT followed by Q.931. Now the last thing that I'll point out here is that if you got that this was H.225, and then part of that was Q.931, you learned that this was an H.225 or connect message as part of that protocol suite. Now if you look all the way at the bottom of this particular hex decode, you can see that 07, which indicates the connect message type, is actually byte number 63, which doesn't complete our assignment. So the bearer capability is a larger field that spans that 64-byte boundary. So I will give you full credit if you got to that message type of connect. I will give you bonus points if you discovered that this was in fact G.711, because this is an important indicator in what we're going to do with this particular conversation. Remember that G.711 is our MuLaw codec. It's one of our very popular codecs that we see on most communication systems. So G.711 is really the thing that we want to use here. Now this one is indicating a law, and we know that in the United States here we actually end up using MuLaw most of the time. Well, that'll about do it. I hope you enjoyed this particular packet of the week, and I hope you got the answer. If you didn't, I hope you learned something with the H.323 suite of protocols and some of the mechanisms that we use to understand what packets are doing. Thanks again for watching, and may your packets always reach their destinations.